In this video, we are going to predict the products for a reaction as well as classify it and balance it. So the reaction we're going to start with is C4H8 plus O2 yields. Now, when we first look at this reaction, so we have two different elements here. We have carbon and hydrogen, so this is going to be a compound. And then we just have O2 by itself. So even though we have two oxygens here, this is still considered to be an element. So when we look at our flow chart, and I do apologize for it being sideways, it's the only way I can get this to fit into the video. Remember, we have element and element, we have compound and compound, we have element and compound, and we have single compounds. Just for our reactants, that's all we're looking at. We're not looking at what the products are, we're just looking at what our reactants are. So with element and compound, this can either be a single replacement, a synthesis, or a combustion reaction. So I'm going to turn it so we can see a little bit easier. So first off, to start off with, does it contain O2? And when we look at our reaction, sure enough, it contains O2. It has oxygen in it. Does it have a Cl-1? So that means, does it have a chlorine that is bound to something? And when we look, we don't have a chlorine here. So that means this isn't going to be a synthesis reaction. Now, when we come over here, does it have O2? Yes, it does. We proved that from over here. Does it have a carbon and hydrogen in it? And yes, we have some carbon and we have some hydrogen. So that means it's going to be a combustion reaction. Now, for combustion reactions, they're a unique set of reactions, which the products are easy to predict. Remember, the products for it are always going to be CO2 and H2O. So we just write in CO2 plus H2O. And that's what you have to do to predict the products. Now comes the hard part of the combustion reactions, and that's balancing them. Whenever you start a combustion reaction, the easiest thing to do is to start off with a 2 out in front. And it might disappear later on, and I'll talk about that, but just to start off with, just start with a 2 in front of your carbon molecule. So now we need to list off carbon, hydrogen, and oxygen, carbon, hydrogen, and oxygen. So now when we look at our reactant side, so the left side of our reaction, we have 4 carbons here, but we're saying we have 2 of the molecule. So if we have 2 of these molecules and each molecule has 4 carbons, that means we have a total of 8. So you can think of this as a multiplier. So the 2 is multiplying into the 4. For hydrogen, we have 8 hydrogens here, but again, it's a multiplier, so we actually have 16. And then for oxygens, we only have 2. Because this plus sign completely breaks it apart. This 2 doesn't affect the oxygen at all. Now, when we come over here with our carbon, we only have 1 carbon. We have 2 oxygens with CO2. We have 2 hydrogen, but we only have 1 oxygen with that. So whenever I write them out, since they're coming from 2 separate compounds, I have 2 separate numbers there. Just so I can kind of keep track what's what. So first off, the first thing I'm going to balance is our carbons. So I'm going to put an 8 out in front. So that's going to change our number of carbons to 8 on our product side. Because remember, this is a multiplier in, and it's the same as saying we have 1. So 8 times 1 is 8. But this also changes the number of our oxygens. And this is the reason why I write it down in 2 separate places, is because now it's easier to keep track of. So 8 times 2 is going to be 16. So I'm going to cross out the 2 because that's where that 2 came from. And we're going to change it to a 16. Next, I'm going to look at hydrogens because I usually leave oxygens to the end. So I have 16 over here, so I have to somehow get 16 over here. So the easiest way I think about it is, what number can I put out in front here to multiply by 2 to get me 16? And that's going to be 8. Oops. So 8, it'll be 16. Because then the 8 times by the 2, But remember, we also have to take the 8 times by the 1 for our oxygen. So that's going to change that to 8. So now we need to add these two numbers together for our oxygens to figure out how many total oxygens we have on this side. So 8 plus 16 is 24. So now we have to come back over to this side and rebalance our oxygens. So since I have 2 oxygens here, so what number here times by 2 is going to give us 24, and it's going to be 12. So now we have it all balanced out. We have 8 carbons on both sides, we have 16 hydrogens, and we have 24 oxygens. However, we're not done. If you look at your coefficients, the numbers out front, you notice they all can be multiplied by the same number, or divided by the same number. We can all divide each one of them by 2, and so that's what we're going to have to go through and do. So our new reaction, or our corrected reaction, should be this. We just went through and divided each number, each one of our coefficients, the front numbers, by 2 in order to get this. And this reduces everything down to the lowest multiple. So that is our correct balanced equation.